Hello, my name is Michael Jennings. I'm the Senior Leader for Weapons Systems Software Sustainment for the Air Force Sustainment Center. The engineering groups of the Software Sustainment Center consist of over 5,000 engineers and computer scientists providing software development capability for the vast portfolio of Air Force weapons systems. I'm very excited about you being here today, and I hope you enjoy learning more about the software engineering groups. Thank you.
Thank you, Mr. Jennings. Hi, my name is Jeremy Peters. I'm the Deputy Director for the 76th Software Engineering Group at Tinker Air Force Base. Today I'll be discussing a little bit more in depth about the Air Force Sustainment Center's software enterprise. So what is software? When it comes down to the very basics, software is really no more than a set of instructions telling the processor how to communicate and how to interact with the hardware, and for the hardware to actually act based upon the set of instructions given in the actual computer software. We'll talk a lot more in depth throughout this briefing about what is software to our warfighters and how it's being used and affects our weapon systems in today's world. So a critical definition to know when it comes to depot level maintenance is it's not the same for software as when we're comparing it to hardware. For one thing, software sustainment is more about continuous engineering. Software sustainment really starts at IOC, or initial operating capability. After that, everything in the Air Force is considered sustainment or maintenance, which is interchangeable. But what you have to realize is 90% of what we're doing with software is either upgrading, modifying, adapting, or perfecting that fielded software to the new environments that it's facing each and every day. So when it comes to software, you've all probably heard of different buzzwords, whether it be DevSecOps, open architecture. In the case of Air Force, many times you may have actually heard of open mission systems and source lines of code. What are all these buzzwords and what do they mean? So DevSecOps. What DevSecOps is doing is bridging the gap between when we develop something, we try to secure it, and the operations. It's really a feedback loop of the collaboration of each one of these entities to create a better overall solution. Many times you may hear in DevSecOps, we're creating automation where we can push this through quicker and release software faster to the field. Open architecture. Open architecture, when it comes down to it, is really how do I interface and make that interface as easy and compatible as can be. So if you think of an open interface for architecture, think about USB. I can plug in a USB mic to my computer. I can turn around, I can plug in a mouse. They're all using the exact same interface. That's what open architecture is really about. So what is open mission systems? Open mission systems is really the answer that the Air Force has come up with to build open architecture for all of our mission systems. So if you think about it, a lot of times you may hear plug and play. What we like to call open mission systems may be a little bit more of a plug and talk. We can interface a brand new radar, pull it into the system, integrate it, and this integration can take just a few days or hours, where in the past it may have taken months or years. Finally, source lines of code. We've heard about SLOC for many years. It's an old metric that we look at, but it's really hard to compare because it's all dependent on your computer program, the efficiency that it was programmed with, and in numerous other things. So it's not always the best baseline of measuring the actual size, but it is still kind of, if I'm looking at a C# to C#, it gives me some indication of the overall sustainment size of that software. So software is really the enabler of our modern warfighter. Everything is controlled by software. If you think about it, everything that we have around us has some form of software. Take out your phones, for example. Look at your smartphone. It's a walking computer. Whether it's on your wrist or if it's at your house, it could be even your refrigerator that's helping you order new things. Everything is controlled by software. It's no different than the warfighter. As we're trying to build new capabilities and enhance those existing capabilities, there's a complete ecosystem of the mission planning while you're on the ground, the command and control of the whole area of region, the communication between weapon system to weapon system, and even the diagnostic and repair when we have to pull a LRU or an SRU off to repair it. All of this is controlled and enabled by software, which is enabling that modern day warfighter. Evolution of flight software. Just as we talked about, everything is growing in software. Our weapon systems are absolutely no different. If you look in the top left corner, you'll notice that as our newer weapon systems come on board, they increasingly rely more and more on software. Back in 1979, when the F-16 first released, only 45% of that was actually relying on software. You fast forward to the early 2000s, when the F-35 first hit IOC, 90% of all functionality relied on software. And that F-16, when it released at IOC, there was only 200,000 source lines of code. And then you look at the KC-46, 15 million source lines of code. And that same F-16, through modernization, through additional weapon system capabilities on that aircraft, is now up to over 5 million source lines of code just to fly that F-16 today. So we've talked about our weapon systems, and you've seen the growth. The same is true for our mission support software. For each weapon system, there exists at least 2 to 3 times that much support software on the ground per weapon system. So for instance, if you look at F-35 that came across with about 7.5 million lines of code, there's approximately about 20-some million lines of code just to support that weapon system in the field, whether that's through lab support tools, to upgrade the systems, to test out the actual software, or simulations and trainers to train the individuals, to train the pilots, to mission planning, to be able to plan that mission, to select targets, to select when you're going to refuel that aircraft in the air, is all done prior and on the ground before that weapon system ever takes off. And maintenance and diagnostics. As we incur an LRU or an SRU circuit card that's went bad out in the field, it's got to be pulled off that weapon system. But we have to create software to be able to automatically run that software, test it out, be able to identify the issues with it, repair it, and get it back onto the aircraft and into a supply chain system. Speaking of mission support software, we have a quick video just to see some of the simulations and trainers being worked on by your software engineering groups today. So you may have heard recently the term software factories. Software factories continue to pop up all over the nation and across our DoD. Here you'll see several definitions of what software factories mean to different entities, including the 76 Software Engineering Group, DoD Enterprise, and the Defense Innovation Board. First off, speaking of software factories, we have the Air Force Sustainment Center Software Enterprise, which is comprised of the 3 software engineering groups at Ogden, Utah, Tinker Air Force Base, Oklahoma, and Warner Robins, Georgia. Together, we have over 5,000 software professionals combined. In addition to the 3 main locations, we have multiple operating locations at Vandenberg Air Force Base, California, Peterson Air Force Base, Colorado, Naval Air Station in Texas, Offutt Air Force Base, NAS Pensacola, and Patrick Air Force Base in Florida. But the 3 software factories made up of the AFSC Software Enterprise are not alone. As you can see, numerous software factories has popped up over the last several years. Now these factories can be anywhere from a couple of thousand, as we've seen across the enterprise, to maybe 10 to 12 in some of these other locations. The bottom line is not all software factories are created equal, and they're focused on different missions and some very specific missions out across for the Air Force and DoD. Looking more in depth at the AFSC Software Enterprise, at any given time across the 3 software engineering groups, we have over 300 active projects, consistently we've proven that we can grow 8% annually and set up multiple operating locations as needed, where we're looking at standing these up for multiple different situations, whether it be co-locating with operating units or working hand in hand with contractors developing the actual weapon systems for our future. Our product lines look at the embedded weapon system, platform integration, mission computing, weapons, air vehicle systems, sensor systems, mission planning, pilot vehicle interface, business systems, and several others. Again, our total workforce is over 5,000 engineers and software professionals. These weapon systems have combined bombers, tankers, fighter and attack, cargo, and even rotary wing, working with special operation forces. Finally, within the AFSC software enterprise, we've stood up our EDGE groups, or referred to as the Extreme Digital Development Group Enterprise. This team is very much analogous to a Lockheed Skunk Works, a Boeing Phantom Works, or Northrop Grumman Advanced Development Labs. These are our brightest, best of best, working on numerous emerging technologies, open architecture, and rapid prototyping. Typically, software sustainment across our weapon systems are not performed by any one entity, but rather in partnerships across industry and organic, specifically being our AFSC software enterprise. Over the next 2 slides, you'll see some examples of each one of our weapon systems and some of those splits between industry and organic. The following slide shows a breakout of our product lines across the weapon systems. As you can see, there are multiple areas in the actual embedded flight software, such as mission computing, electronic warfare, radar, stores or weapons, and communication, navigation, identification. On top of that, we have a large area of mission computing, mission support, and other entities such as business enterprise systems. In any given year, across the AFSC software enterprise, we execute approximately 5.2 million labor hours. As you can see in the top left quadrant, the AFSC software enterprise continues to grow year by year, and it doesn't look to stop anytime soon. Looking at the top right, you can also see that our age demographics are quite equal across each one of the categories. The bottom left will actually show you the combination of what we are employing within the AFSC software enterprises. As you can see, nearly 80% of the job series are made up of engineers and computer scientists, with IT specialists continuing to grow and grow, as you can imagine, with the cybersecurity and cyber workforce now needed for today's weapon systems. Bottom right will also show you, in addition, that over 80% have at least a bachelor's, if not a master's degree within the software enterprise. To meet the growing demand of software professionals, we're looking at recruiting across 85 campuses in 24 states. We're consistently gathering resumes, transcripts, and interviews, whether that be virtual or in person, to help grow and meet the ever-growing demand. Another way that we're looking at growing our demand is through our internship program. Our internship program is consistently converting 70% of all interns to full-time employees upon graduation. Each one of our software engineering groups has set up educational partnership agreements with multiple universities surrounding its community. For instance, Tinker Air Force Base has set up an educational partnership with both Oklahoma State University and the University of Oklahoma, and is currently seeking an academic partnership with Oklahoma Christian University. Within Department 70, or part of our EDGE team, they're working with the University of Oklahoma in artificial intelligence, machine learning, multifunction digital arrays, and weapon system software development modernization to bring that research and integrate back into our weapon systems of the future. In addition, Oklahoma State University has partnered with Tinker Air Force Base to look at different ways to enhancing their engineering community to be ready and able to software code for the future by ways of developing a software engineering option to their electrical engineering program. Similar to Tinker Air Force Base, Hill Air Force Base continues to grow its ecosystem not only in Utah, but also at its operating location at Colorado Springs. The software engineering group at Hill Air Force Base is working with multiple entities to create an agnostic atmosphere of cutting-edge activities in support of their Edge group and also Ski Camp to tap into the local community resources and also the nationwide DoD software ecosystem network. Finally, our software engineering group at Robins Air Force Base is partnering with Georgia Tech Research Institute, Mercer Engineering Research Center, and Middle Georgia State University to innovate and develop new capabilities for our warfighters. In addition, they continue to build their software brand by participating in multiple STEM events, partnering with the Houston County Board of Education while growing internship programs and increasing marketing exposure through social media. Finally, Robins Air Force Base is partnering with Houston County Development Authority and the Board of Education to establish a 43,000 square foot facility to house modern software development and showcase local STEM activities in this partnership. Let's take a deeper look into the software innovation initiatives within our Edge groups. As mentioned earlier, Edge, or Extreme Digital Development Group Enterprise, has been stood up across the AFSC software enterprise at Oklahoma City, Ogden, and Robins Air Force Base. Their mission is to research, develop, and apply innovative and emerging technologies to our weapon systems. We stood up our first Extreme Digital Development Group Enterprise in 2017, focused on innovation to rapidly develop, integrate, and deliver advanced capabilities. As we continue to grow our Edge groups, we've looked at academia partnerships, working with industry and research labs. Edge OKC is broken down into three major entities. First is our Next, or Advanced Development, our Thunder Camp, concentrating on DevSecOps, and finally our Department 70, our Applied Research Team. Under Edge Ogden, we have Opal, which is working to develop machine learning and artificial intelligence for the weapon systems. Ski Camp, which is much like Edge OKC's Thunder Camp, is working to bring DevSecOps to each weapon system. And then finally Skyborg. They're working to not only take the cloud to the jet, but make sure that it's brought in a secure, efficient, and effective as possible for the embedded platforms. Finally, Edge Robins. Underneath we have Infinity Edge, the Vulcan Project, and Ducky. In concert, they're working to innovate our weapon systems in addition to bringing additional intelligence through machine learning and deep learning systems. The AFSC software engineering groups are uniquely positioned to drive digital transformation across the entire Air Force portfolio through the people, our infrastructure, and processes. We possess a unique set of expertise and resources to continue to deliver warfighter capabilities in the past, today, and in the future. Each one of the software engineering groups are led by a director along with a deputy. Underneath the groups, we have 5 squadrons for production and support branches. In addition, each one of the groups has multiple technical advisors focusing on different areas. '76 Software Engineering Group is focused mainly on bombers and tankers, in addition to jet engine tests, diagnostic repair, and E3. The 555 Software Engineering Squadron focuses on the KC-46 Operational Flight Program, or embedded software, along with jet engine tests and trainers. 556 main focus is diagnostic repair and system integration lab management. Moving over to the 557th, we have B1, B2, B52, and E3-E8 mission planning. In addition, we also have B1 and B52 operational flight programs. The 558 focuses on E3 mission computing, radar, electronic warfare, and the overall software system integrating for the entire weapon system. 559 focuses on advanced bombers, specifically B-2 and B-21 operational flight programs. Moving on to the 309th Software Engineering Group, under the 516th Software Engineering Squadron, we have space and ICBM or missile software, along with diagnostic repair or automated test equipment and automated test systems. Under the 517th Software Engineering Squadron, we have GBSD, GPS, range systems, MIL SATCOM, PRC-2 or Personal Recovery Command and Control, and F-35. Under the 518th, we have F-16 Block 30 OFP, or again, embedded software, F-16 Block 4050 OFP, NQ-9 Tactical Situation Systems, and the T-7 OFP and trainers. Underneath the 519th, we have trainers and simulators and mission planning. Finally, under the 520th is A-10 software or embedded software, space support, command and control, and business systems. Finally, at the 402nd Software Engineering Group, underneath the 557th Software Engineering Squadron, we have DCGS, or Distributed Common Ground Systems, or UAV, or Unmanned Automated Vehicles, and finally JSTARS. Moving to the 578th, we have F-15 radar and embedded OFP, in addition to tactical data links, C5 software, AC-130 for the SOF, and finally F-35. Underneath the 579th, we have our electronic warfare systems and F-15 jumps, or mission planning. Inside the 580th, we have our C-130J workload, along with our HH-60 helicopter. And at the 581st, we have F-15 IMIS, armament or weapons, diagnostic repair, and our business systems. In closing, software is a catalyst to bring new capabilities and enhancing existing capabilities in our modern weapon systems. Software is a critical component of our defense industrial base. And it's also an integration force multiplier. When saying this, if you think about it, all of our weapon systems are interconnected together. How can we take that connections, share information back and forth through software, through multiple systems to create a better, enhanced vision for our warfighters in the field? Software poses unique challenges. Organic entities must work to develop with industry during engineering, manufacturing, and the development phase. We need to consistently work on building effective partnerships with our industry to become enablers for our warfighters, along with managing our risk to make sure that our weapon systems of the future are affordable.
We hope you've enjoyed our overview of the Air Force Software Enterprise and you've gained a greater understanding and appreciation of the work being done here. Our overarching mission is providing agile, war-winning software to the warfighter at the speed of relevance. As you can see, the organization as a whole is a critical cog in our national defense strategy. Thank you for being here today,